What's up, Schleif squad? This is Dr. Schleif with another paper 1 worked example, which reads, a jet aircraft travels at a speed of 0.8 v, where v is the speed of sound. The aircraft approaches a stationary observer. The frequency of sound emitted by the aircraft is 100 hertz. Which frequency does the observer hear? All right, so this is a Doppler effect question, and we know that the observed frequency is equal to the frequency of the source times the velocity of the wave divided by the velocity of the wave. And we either add or subtract the velocity of the source in the denominator. Because this is an approaching type problem, we should subtract. So anytime that the source of the wave is approaching the observer, or the relative motion of the observer and the wave source are moving towards each other, we subtract. If they're moving away, we add in the denominator. All right, this question is unique from other Doppler effect questions because we're given the velocity of the source as a fraction of the velocity of the wave. We're usually sort of given values for that. So let's just try to make some substitutions and see if we can't solve this thing. The frequency of the source is 100 hertz. So 100 times v over v minus 0.8 v, right? The velocity of the source is just, 80% of that velocity. So the observed frequency is equal to this. And what can we do with this? We could write it like 100 v over v times 1 minus 0.8, factoring out the common v, and then v divided by v is 1, and 1 times this is just all this. And so this becomes 100 divided by 1 minus 0.8 is 0.2. 100 divided by 2/10 is 500. So the correct answer is choice 2. You don't need to be given the speed of sound because there's only that single variable to solve for. So we just have to be clever with our algebra. This is another worked example with Dr. Schleif. We'll see you next time.